Hi, welcome to the third video lecture of this series. Myself, Palash. Today, in this series, I will show you the MATLAB codes of particle system optimizations. This course is successfully running, and so let's run the codes and you will change the code. And in this section, I will discuss each of the lines one by one. That will be very suitable for you and that will be very understandable. I think so. Please bear with me and learn the particles of optimizations codes in the MATLAB environments. Okay, before that I will recapitulate the things, some things which you that so whatever I discussed in the first two sections. Those of the people who till now not visited or not watch my first and second video lectures, please go to the video lectures and watch it. So it is a basic concept of articles of optimization, so how the learning the movement and so from the learning and movement they're going to find the optimal solutions here. And so there's the equations about the particle velocity and the position change and some of the parameter of particles of optimizations. And this is the velocity discipline of particles of optimizations. And it is the best of local waste and global waste, and how you calculate the local waste and from global waste from local waste and how to find the local waste and global waste from the personal waste positions. This is the discuss about that. And that is the construction coefficients, why we use construction coefficients and the values of the construction coefficient. I will come to the next sections. And in some of the feature of particles and optimizations they have, and the data flow diagrams or DFT diagrams, or you can say it is the flowchart of particles and optimization and the pseudocodes of particles and optimizations. So I will okay, here that's the environment will introduce to you MATLAB. That is the MATLAB environment, and I'm using it to write the code with MATLAB 2017. 2017A. It is a very useful and choose the MATLAB. It is easy to learn and very simple. Very simple to write the code. I think it will take just a very short time and very limited time to implement any code in MATLAB also. So let's see how introduce from the topic is the MATLAB home. So in the MATLAB home, there is a number of things. Here, homes, you can plot anything. The apps and the editor is the published and is the view of these things. So our introduction is not like that. So it is the MATLAB code writing editor, and so it's in the current folder. You are under in which folder and how many files is file and folder is there. So it will show the information about, and it's in the workspace. After running, how many variable you declare each of the variable and their type of the data will show here. Okay, in table format. Okay, fine. This thing is the command window. It is we are using for running in code or to do simple calculations here. So let's start with the very basic codes here. Like e is equal to 2 and e is equal to 3. So a plus b, what will be give? It will give the value of 5. It's a very simple. To run a particular code, if you write the just file name in which file you saved, it will be run. Let's see, I'm creating a new node from class here. Okay, neither if there's another way, just edit uh, example. Example. I mean, this command is meaning is by example. I want to create an example new code editors in the home space. Let's see. Yeah. Let okay, so it's from here. No problems. Examples. Example is in here. Okay. See, example is created here and example is now is here. So write some things. Equal to and semicolon. So B into C. So here let into semicolon and C is equal to and A plus B. And by this line we just just the value of C here. C is like this, and sorry, display of C. Okay, and type C. Let's save and run by F5. You can run it with, sorry, you can run it with F5. You can run it the things with the F5, or you go to the editors and program. Okay, so it's successfully run. Yeah, the log C is 5. You can type example here. Example, it will show the same output. Now to clear the window, CLC, CLC clear, close all the things, close all, clear all the variables used before, clear all, and type CLC. Okay, fine. So come to the next sessions. Our intention is not like that, so I'm deleting the code here from delete code, example codes, and it is a main particle sum optimizations code. So let's get started with the particle sum optimizations code. Before that, mm, I think we'll increase the size, no? I think it will be better. So go to the home screens and come to the preference and increase the size. I think it will make it 50. So I think it will be good. Apply. Okay, now it is good for views. This code is successfully running, so no problems about the things. In this code, you can evaluate in the parts of the sections. Evaluations means to see a particular value. Okay, you can see. Suppose you want to see, suppose particle size. Particle size, to see the particle size variable or each of the line variable. What will you do? You will select the whole things. And after that, you will come here and press on evaluate sections. 8 lines. Okay, I will not do here because neither my voice will not be captured in the screen capture. Or if I press F9, then my recording will be going to stop. So I will show these things in the last of the sections. That time the voice will not be recorded, but it will be successful. So let's get started. If you have a doubt into the code, your code, you can select and you can evaluate these sections, particularly these sections, to see its value. So let's get started of particle sum optimizations. This is my codes, this is the information. So if you face any problems, if you need the code, you can mail me. If I notice these things, I will send the codes as a preference. Those of the and before starting these things, I will talk about some things. If you want as a project of the particle sum optimizations, you can take these codes. It's the 100% free and 100% free, and it's the completely stable codes for particle sum optimizations. Okay, you can modify the codes by changing the names and changing the parameter and having no problems. Now, discussions one by one. It is a clearing window variable command. What tick, and at the last C there is a tock. Tick tock. Tick tock is a calculations of times. I mean, I'm calculating the time to run all the programs previous and tick and at the last stop. Clear all, it will clear all the variable, all the space variable, and close all, it will close all the window that is open before. And CLC clear, then clear the command window. So this three line is very useful. Whenever you write the code, please use these three lines before. If you use a variable with the same name before, and then it will be coincide and make it conflict. So that's the reasons. Please use these three lines to clear the window and clear all the variables that you used before the command line command window. Now come to the initial particle sum optimizations parameters. There is a number of parameters is there. So let's introduce the min max. Min max is equal to 0. It is to calculate the maximum of the minimum and maximum epoch. How many times it will iterate, how many times the code will be done. So, I mean, each of the iterations will be done. So it's 100 times. Particle size I'm taking as a particle size is 100, and maximum velocity of the particles will be 4, and accelerations, I mean C1 and C2, those are the accelerations coefficients. C1's value I'm taking as a 2 and C2's value also I'm taking as a 2. And initial iteration so wait, and there is the only iteration so which is W. Let's say that the sections, this section, so there is the only iteration so it is omega. That means understands omega is omega. But here I'm taking 2 omega as the initial iteration so it omega and with the finals. Why? Because to form the initial and final iteration so there is a formula uh, to take the omega c values as the final value, not by assumption but by as a proper formula. And the initial iterations, how many times the iterations will be updated? So it will be evaluated as a 100 as a particle size optimizations value. And d1 is the 1. What is d? D is the variable that is declared in the objective functions. So what is the objective functions? Objective function I am declared here, it is the objective functions. The functions will be declared in like this way, addition functions, and function value is coming as in out, and the function name is objective and obj, and the functions have the variable only x, only single variable. If they have any functions that have multiple variable, then we will write the variable by separated comma. So let's so what's the functions? In the functions, so the out is evaluated from the functions, and the function is x into 10 into 5 into x plus 1. So it is a complete function. In this function, in these functions, we have only one variable that is x. Neither there is another variable is pi, but pi is defined in MATLAB. It will takes automatically the value of the 3114. So in this variable, only one variable is there, x. That's why we take d as a 1. D as a 1. It is about the objective function that we want to minimize the objective functions. Our optimizations is there. Our goal is here. We want to minimize the objective functions value. Now introduce the constructions coefficient. Constructions coefficient is the here. Here is the constructions coefficient equation. Here is the C and phi. Those are the things, and it is given by the equations. I already talked about the construction functions. So, sorry. So construction function I'm taking as a Kafka. Kafka is a key. Okay, sometimes beside two here, beside two, someone used k. I mean and it is a value of 1. If you want to use it, no problem. If you don't want that, then it's also no problems. So Kafka is 1 and phi 1 and phi 2. Why I am taking phi 1 and phi 2? Because phi value, what is the phi? We are talking psi. Its value depend upon two of the variable phi 1 and phi 2, and the phi value will be greater than or is equal to 4. That's why we're taking two variable phi 1 as well as phi 2 of the value 2.05 and 2.05 each. Now from these equations, we're taking the phi, where phi is the summation of phi 1 and phi 2, and psi is another variable. So what we are actually calculating the construction coefficient psi. This psi is given to the equations of this. In these equations, we can calculate the construction coefficients of particles from optimization. Now come to below. Here, creating the domain or the search page. In the search space, where particle will be moved. So search space have some upper limited value and some lower limited value. This is the particle upper lower limited value. Variable mean. We are meaning variables mean, where it will create one d. What is d? And this is the variable size which value is 1, 1, I mean it will creates only single one, and single one is multiplied with -1. I mean variable mean is -1. This way we are calculating the variable max as 2 by this equation, and the variable range will be variable mean to variable max. It is the variable range. Within the search space, the particle will move and all the other things will be happy in the search space. Okay, come to below. Utilized popularizations for particles and their velocity. So in the start space, we need to spread the particles randomly and we need to set the velocity of each particle. So how we will do that? So we take as a for loop within the for loop space 1 to d one to one for one time particle positions. What will be the particle position? Particle positions will be from 1 to particle size, 1 to particle size with 100 and incremented with space. Space means 1. For each incremented 1 to 100, each incremented 1 by 1, 1 up to 100, it will create the particles and the particle is created by these functions. Normalization of particle positions. Particle positions where particle will be distributed into randomly distributed where the particles will be distributed in the particle size to one in space up to the space where they incremented with variable range. So let's see the particle how creates the particle random particle with the function value of norm pos. Norm pos is the function that I declare here. Norm pos is like that. Normpose is taken as a function giving some output and function is the name of normpose. The normpose have some variable. Sorry, variables have these functions. These variables are viewer variable 1, decrement T-I-M-C-N-T and variable 2. We are calculating here x1 for maximum of variable 1 and x2 with the minimum of variable 1 and y1 is a variable to decrement of 2 and y2 is a variable 2 of decrement 1 and we are using this formula to normalize using two equation and we take this equation to distribute the all particle in the domain space. Okay, here in this formula we're using the functions here to distribute all the particles within the search space from randomly from particle size 1 to all the space over the space with increment of variable range. Like this way, we are also distribute each of the particles value of the velocity. Particle velocity will be from the 1 to particle size for the incremented and space, whatever the space value, and we have distributed it in this function value known as the normalization of particle velocity. By it is also given to the randomly from particle size to 1 and maximum velocity we are giving this velocity and non-positive is the particle velocity. How we give the velocity to each particle is defined in this functions. But the function name is non-post p is this equations and functions evaluate the output and functions that have a variables that one max variable where it's also calculated the same way in the normalization of two equation right. We are using this function to distribute all the particles velocity within the search space of minus 1 to 1 instead. Now come to here. So particle position for velocity is settled. Now into previous positions value. So we need to find the particle best previous positions. Particle each. So at the first time, each of the particle is the position is their previous positions. So we will declare these things here. Part P best is equal to particle position. So whatever the particle position, it is their previous positions. And for GA to 1 to particle size is 100. So for this space, numeric is taken as a 0 and for 1 to t and for one time iterations just do one time numeric in is equal to star cat. Star cat is a thing that you concatenate the thing. Suppose you don't know the star cat, suppose you come here and come to here and type help space the thing. It will give the idea about star cat. What is a star cat? Star cat is a concatenate text. It's known as star cats. So like this way, it is concatenate the numeric means for the particle position from J to I. So Everest is the Everest also another type of things we are making anything to double. We are using this thing ever best where this target value whatever we get we are make this things in a double type statement. After that, whatever the value we are getting from here, we evaluate of evaluate TRG. This value we are storing in our chain in this variable. So evaluate the diesel functions with particles J until the end of the loop. After that, this energy, these values we are storing. If you want to store in the text space, then don't worry. If you don't want, you no need of this line also. Okay. Now we are ever based what are doing we are particle based value is out. Whatever we get in the out, we are assigning the out value to the particle based values again. Initially P based is the same as particle positions. That's the main intention. What about the first position? In the first iteration, before iteration start, each of the position is the particle P based positions. Now we are going to try to another statement assigning initial G based value from the particle P based value. When we get the particle P based value, if you give me the particle P based value, then it might be possible, or it is obviously we can ensure that from the P based value you can get a based value which is known as the G based value. So we are calculating the G based value from the particle P based. For min max is equal to 1 if the G based value and ID is 1. In this boundary we are maximize the previous value, and else if in min max is equal to 0, then in this domain space we are minimize the previous value, and gvest value we are calculating the previous value of in this domain. In this domain we are calculating the previous value, and previous value we are assigning as gvest, and gvest value we are assigning as a tr1 again. Set the output type of double. Tier 1 is the save the GS value in type of W. Okay, so here we get the G based value, global based value from the particle based position and P based. Then start PSO iterations processed. Now we need to start the iterations process of the particle sort optimizations. And how many times we do iterate? 100 times as we declared before. So if print, coming to the sections later. Just bear with me just for a few seconds. Okay, if you change anything after that, you should have to press Ctrl S to save. Okay, now fine. Now assigning the GBSD values, we are iterating the particle iterations process. How will iterate the particles process? From CMP count, it will count as 0 for only one time. Okay, particle from 1 to 100, and for G is equal to 1 to particle size 100. For each of the 100 times, we will evaluate for each of the particle 100 times, where particle is equal to J and new now int is 0. So get new velocities and positions. Before that, in this case, this here we are generating the particles iterations with W, inertia with what is known as inertia with. So in the first I told you that inertia with W is a single value, but to calculate the inertia weights properly, we are taking the help from inertia weight, inertial initial weight and final weight. So initial initial weight is coming in this equation that initial final iterations weight minus initial iterations weight divided by iteration number of iterations times, and it will be 100 minus 1 into I minus 1 is equal to 100 plus initial iterations weight. That is the formula to to calculate the initial weight by this formula. If you take the initial weight like this way, it will be a unique value. Neither you can take it as a your as choosed value and then no need to declare the initial values like this. But it is the very suitable, and this concept I am getting from the book of soft computing written by Simon Badhe. Neither you will take as a initial weight as a final initial weight. If you want to take as a initial, you can take. Okay, and then within it is within else conditions. Now, now for the soft space domains 1 to D, what happens? We are creating uh, some random numbers. Rand 1 is a random number, is a rand 1, and rand 2 is another random numbers. It is created by also random 1 to a distance random number, and the random number I am storing here ncg1 and ncg2 I am storing here. Now calculating the particle velocity updations, which is over it will be over in g2 space in this space is equal to psi c. It is a construction coefficient and inertia weight and particles velocity space from G to space. In this way, we are calculating this first, and this is termed known as the inertia component. And after that, we are taking the acceleration coefficient of 1 and the random number of 1, and here and the particles previous positions is subtracted with particle positions. And this is the uh, cognitive components in this is known, and the third one's also C1 plus random number 2 plus global based positions subtracted from the particle positions. This is the known as the social component. As I discussed before, here we calculate the particle velocity. In this velocity, we are using the psi to control the uh, velocity of the particles that is mentioned. So here with the commented lines. Here, whatever the blue lines, okay, in this blue line, whatever the ratings in the point, uh, this line will not be evaluated. In MATLAB, those are the lines, if you using any of the lines before in percentile symbol, then it is made as a commented line, and this line will not be evaluated with particles and optimizations or any MATLAB code. Who get update to understand at a glance at a quick views to using this thing. If you are very genius, then no need to write the two lines codes, I mean commented line. Now we need to update the particle positions as well. So we are using the particle positions updations from here. Particle positions will be the particle positions plus its velocity, whatever we discussed in the first lecture's video as well as in the second lecture video. By these equations, particle list update its positions in these equations, and the particle velocity is storing, and the particle velocity p. In this variable, we are storing the particle velocity here. Okay, no problems. Now limit velocity positions compared to maximum extremes. In the particles of optimizer, there is some boundary limit of the particle positions as well as some boundary limit for the velocities also. If a particle position is fall down rapidly or is going down the maximum it reaches to the maximum velocity, then we will set these positions to upper bound as well as lower bound for the velocities also. If a particle velocity goes and rapidly, increase rapidly, and it is exceeds the boundary limit of upper boundary limit of given, then we will set the particle velocity to the upper bound as well as vice versa. Will set the lower bound limit to the limited value. So in this case, for space 1 to D, what happens if the particle velocity for G2 space is greater than maximum velocity, then we set the velocity as maximum by the equation is equal to set the if particle velocity is less than of maximum velocity minus maximum velocity means it is a minimum velocity. Okay, another name is minimum velocity from the body, and we said particle with velocity to it is equal to okay, minimum velocity or minus mass velocity. It is a velocity aberration change of distance, and it is a aberration change of the positions. If the positions is greater than in the search space of 2, then we will set the positions in the maximum value of variable in space 2. If it is less than the variable space into 1, then we will set the value of the particle positions in the variable space of 1. Okay, so in this 8 lines is for particles, positions and aberrations, violation chains value. After that, the end statement up to the here is complete. Now for this space 1 to d, we are calculating the integer we have started, and it is concatenating the numeric integers, and it's converting the number to structures of particle position in the space. After that, we are ending this for loop, and ever starts we are calculating ever struct to concatenate and to make it the double type variable of star cat, where the value of numeric integer from 2 to n. This value we are making it first concatenate, and we are after that making it into double type variables. After that, this value is storing to outj, and outj value is storing to ej. Why? Whereas to perform the next sessions, we are evaluate the value of the ej, and where ej is the minimize or maximize functions value. Okay. Now update previous to reflect subject for max or minimum of the functions. So in this case, if min-max value is equal to equal to 0, then the particle p-based value, what is the particle p-based value? This value, if is greater than e of g, I mean particle function value, if the particle function value is less than, I mean actually less than the particle p-based value, then what will happen? There is no updations of change. Then E of j values is updated to particle j based value. Okay, because it is already list, so we need to maximize and minimize this. So if it is list, so we reset the value as a particle p based value. Okay, and p based is updated at particle based position is the p based of j for all, so it is updated. And another statement we can say if min max is equal to 1. Okay, for maximization case, so what happened in the particles E of j value, and the function of the value is less than greater than a particle based value. So no need of change. I mean particle based value will be the particle based values. So particle positions, whatever the particle position, it will be the particle based value or particle based values. No need of change. When it is less than, one is less than, then update. Then it's update with the equations. Neither no need to update. So it is about the particle p-based evaluations updations. Now assigning g-based by finding the minimum of all particle p-based. So we are finding the g-based value from the minimum of the particle p-based value. We are getting the particle p-based value from the particle p-based value. We will search for the g-based value. How? Let's see. When in the minimax is equal to 1, in this case, in these domains in space, if it is maximum of particles, it is we are searching for maximum case, if it is maximum, and this case if g based value is less than of iterations based value, then what will have a g based value will be assigned as a iterations value. G based value will be assigned as a g based value, and g based value is updated as p based of IDA x1 for all column means from all the values from these rows, and column means from all the rows. Okay, will be updated like this. If min-max is equal to 0 and for this domain space, and we are finding the minimum value of the functions and of the particle that we used value. If in this case, if it is happening that g based value is greater than the iterations based value, so there is no need to update the value. So we'll take as the iterations based value as the g based value, because g based is already based. So we are assigning the iterations based value to the G based value, and here update the G based as a P based of this value, update the G based value. That's like before this statements. Okay, what doing this statement I will describe here, it picks the global best of only one to minimize the functions. It is the minimization case, it is for the as well as maximization case. From the two values, it will be updated. Here means from the, transitions or iterations updated for each of the one time with increment of one, and g is incremented of one, and this value is here will be stored and I will be stored here. Okay, so I means 100, I means 100 means tier means 100. It is actually the iterations number, how many times it will iterate, and if you increment the iterations concept comes from here. Now we need to um, figure it out. Sorry, not to resolve it. So we want to G-based plot. Want to G-based plot. Suppose G-based value, we are assigning G-based value again to the G-based plot for all I and for the first column. And we are taking that if print. If printf is if printf after that fast packet within single quote or double quote, whatever you write, it will print automatically mm, all of the things. Okay, so we are writing this statement that will display in our command window. We will evaluate the result, and here class ends is the total number of new line for each of the iterations, and it is and so number of evoked whatever the result, it will comes in a format of percentage of each. What is percentage of each? Percentage of each is a digital value. It will evaluate digit up to 8 number. And particle variable based variable, it will evaluate is a floating variable. F means floating variable, where the number of um, before the decimal will take as 8 digit, and after the decimal will take as a 4 digit. As well as best solutions after so far, whatever the solutions we are getting, so for each of the iterations, it will take as a format of in float also, where it will first before the decimal it will take 8 digits, after that it will take decimal, after that it will take after the decimal 4 digit, and it will use 4 type variables. And slash end, it will give number of new lines for each of the iterations. What is the value? Then number of iterations evoked is the TE. Actually, it is TE. If T is incremented as value 1, 2, 3, 4 up to 100, and so it will take creates the iteration number of iterations 100, 1, 2, 3, 4, 5, 6, like this way to 100. And G based, mean the global based, it is the best values of the variable. So the best variable value is printed over here. So G best, and best solutions often so far it will takes the global based value, I mean G based value. This value is will take the global best value as the G best. Up to this is complete. After that, for each of the iterations, it will create a new line. It will generate the value, and it will print the dot lines, these lines, and this is the end of this. Up to here, your program is complete. Now comment this line. To comment this line, right click, come here and comment. When you make the line comment, so no line will be evaluated during the program running. So evaluate the line first here to this whatever we did. So before going to run the program, please save. When you run save, let's see, when you give a space to modify something, there will be a dot. Okay, let's see here in ps.in there is a star. I mean the program is not saved. When you save the program, the star will not be there. Let's see, Ctrl S. Program is saved. Now let's run the program. You can run the program in three ways. The first way is directly press F5 in your keyboard. Second method is go to editors and there is a run, press on run, it will be possible. Then another procedure is just come to the command window and write ESO. Okay, if I press enter, it will be run. So let's run the program. I'm entering here. Run is run. So both program takes in the time of 9 seconds, 9.78 seconds like that means, and it is generates number of epoch and the best variables for on the particular epoch and best solutions of trend so far on the particular epoch. This is the let's say it is the different value for number of one epoch, it is different for number of two, it is different for number of three like this. It will different. So it will not look very good. So let's go to the programs. So what happens in this line code, it will evaluate it number of times. So we want this line as the only single time. So what happened? Cut this line, not less, and go to the very top of the for loop is started. Before that, here's put the line here. So it will use only one times. Okay. What happens? So it will also comes in the number of times. So no need of this is to print it number of times. But this is and print it here only at the last. Save the programs. Okay, after saving the programs, what happens? Now you run the programs from here. Editor, run. Now the program is running. And let's see, it is a good example. Number of particles is this, and it is the number of iterations, number of best value, number of solution options. So far, it's this. It's quite good type. Okay, now I want to do another things. I want to figure it out a plot. So make me uncomment. Right click uncomment. So all the line will be evaluated. Here I am evaluating a plot. Which plot figure name is figure 1 and want to plot from 1 to 100. I mean it is iterations. Okay. In this way you can instead of using 1 to 100 number iterations, you can take only TE. You can take no problem. TE. T is the number of iterations. Yeah. From here, remember. So and the GBS plot. GBS plot means GBS value whatever we get in the GBS plot, we want to iterate number of iterations along with the y-axis GBS plot, and this plot will make practice things. Not now. I think it will be okay. Just think now. And further I am describing the x level as the number of iterations over the epoch, and y level is the best variable for the goal based positions. And I am giving the title of the figure is the title of convergence plot using particle sum optimizations. And listen, listen command what it does. Listen command to write something within the plot that will mention the colors of the light, and it tells about the line, something about the line. In the listen line, see, it is uh, written over here like this. First, with a single quoted up to here I'm written. Okay. After that, it will not to write rather than write a full code, full line inside the thing. I'm using here a new thing, a new line. New lines I'm using here separate plus second line. I mean this line will come to the next of the first line, and after here it will print first, after here it will print in the second. In these two lines I will separate by the new line command, and I want to grid on. Okay, you don't want grid on, no need. So I comment it, okay, it's grid on now. So it's about. So let's set the program and run the programs. So when we run, I'm now running with F5 in keyboard. Okay, the program is run. See, it is busy. Program is running. Let's see. Program is starting. Yeah, fine. Uh, graph is not coming here. Maybe some of the problems. So let's go to the code, and now I want to grid on the code. Here I'm using the one thing, comma p. I mean minus with a single quoted minus star. Green means it will generate the code. I mean this line. It will make suggest this line will make as green lines. If we come, let's look. Okay, up to here is fine. So I changed the here. So put it here whatever have before 100. Yeah. Okay. So P is not fine because P's values is here up to here because the end loop is end here. That's why T's values is not found in the figures. Okay, whatever it is found only for one single value, but it's not able to plot it out. That's why it takes a single point and it is unable to make it a graph because within single point it is not able to plot a graph. So we are using the here 1 to 100 iterations and GBS to plot and make it with the grid lines, and we want to the figure as grid lines. Okay, so now let's run the code from editor. The code is running. Let's see. Yeah, now it is the fine. Obviously, see it is a inline command of listen. I'm using here in the between new line, that's why this line is going to the next and the grid I make it grid on, that's why it is grid on. Okay, so this is fine, no problem about the codes. So it is a 3D plot. Okay, if you want to plot your graph in 3D, you can go to the 3D and make it whatever you want. MATLAB is really fine. Really, if you want, it is see number of iterations is like this way and the best value is like this way. So in the plot is here. No, don't make mistakes. Okay, now it's about the particles of optimizations. This particles of optimizations code is very stable. You can improve the particles of optimizations this code by changing its parameter value. I told the parameters values here some constant values as my assumptions, but as your result expected, as you want to minimize the functions, you can take number of values for that. But it should be, it should have a reason behind that why you take the value. Okay, instead of taking number of iterations, one is not possible. If you are taking number of iterations is like one line, it's also not possible because it will take too much time. And it is depend on the objective functions also. My objective function is this much only, so it is very simple. That's why I'm using those are the equations, those are the parameters values as particles of optimization value to evaluate the result. But you can improve the particles of optimization with this code by taking your values. So this is it is a complete particles of optimization code. Don't worry about that. If you have any doubt, if you have any questions, you can put me the mails into my mail ID. If I'm free, I will obviously give you some expected as my level first response to you. One more things. Suppose you want to evaluate something after this. So if you come here in this line, okay, and press click. Okay. So before that, all of the lines value will be evaluated. When you press here, so now if you run the code, okay, so what will happen? All the value will be evaluated. Up to this much value will be evaluated. You want to see? So let's see. Yeah, let's see. Now only this value is evaluated. See, up to this, only this value is evaluated here. None of the other values is evaluated because you have break it from here. Okay, you have break it from here, and if you come to the cursor here, uh, let's see, this values is 1, this values is 100, this values is 4, this values is 2. This is amazing, amazing. Okay, I mean break the here and break the code to two sections, and I'm telling the MATLAB that to run the code from very fast to up to here. Before that, run the code only, and after running the code, no need to see the all values. Just come here and put the cursor over there. It will automatically see you the values. It's the amazing thing. Okay, and just make this one. Okay, now fine. Suppose in this efficiency, if you want to see a particular line value. Okay, suppose you run the programs. Sorry, the figure run the programs. Program is running. Okay, the program is running. After that, you think you want to see any particular value, or before running also, if you want to see any particular variable value or any particular line value, how can you see? You can see it like this. Suppose I want to see, um, suppose I want to see particle variable. What is the particle variable? To say this, just select that these things, except the semicolons, come to here and press F9. Evaluate sections, then it will generate only the VR value. Okay, and neither you will press the F9s. I will not press here. Neither what happens, my recording will be stopped. That's why I will do press here F9s, because I faced the problem before. So it is a complete code about particle sum optimizations. This code is taking from the help of, I mean, main creators me. Along with that, the help is from as it, along with that, Simon and Pathy soft computing book. Along with that, Jyotish Kumar book also gives me the great idea about the particle sum optimizations. So today, up to this is enough for you, I think. So have a good day. Bye. And at the last, I would suggest you, if you please like my video, subscribe my channels, and please click on the bell icon for new update, and that it will makes me motivate to create lot of video related like this. Okay, so thank you so much. Goodbye.